this video, I'm going to go over solving different logarithmic and exponential equations. You'll notice as I go through these, I'm going to do 6 in this video because they can be pretty time consuming. And I didn't want this video to be too long, but you can check out my key on Canvas and then come see me if you have any questions on solving these. We're also going to practice a ton of these in class. Okay, let's start with the first one. So when I do a logarithmic equation, as I mentioned in a couple videos ago, I really have two things that I'm trying to accomplish. Either I get 1 log on one side of the equation, or I get 1 log on each side of the equation. And I've actually already accomplished the first one that I mentioned, which is 1 log on one side. So I'm going to rewrite this to be an exponential equation. So take my 2, raise it to the 3rd power, and equal to that large argument. So 2 to the 3rd power equals 3x minus 7 times x minus 4. Now I'm going to go ahead and distribute the right side. So 3x times x is 3x squared. Then I have 3x times negative 4, which is negative 12x. Negative 7 times x is negative 7x. Putting negative 12x and negative 7x together is negative 19x. And then negative 7 times negative 4 is positive 28. Now this started out as a logarithmic equation, and now you'll notice that it has become a quadratic equation, something you've already hopefully mastered in this class. So move the 8 over with subtraction, and you get 3x squared minus 19x plus 20. Now check for any GCFs before we start factoring, and unfortunately there's nothing I can factor out of all 3 of these. So I'm going to go straight into my tool here using my x. So a times c that adds to b. A is 3, c is 20, so that's 60. And b is negative 19. So I need 2 numbers that multiply to give me 60 and add to negative 19. That's negative 15 and negative 4. Now because my a is not 1, I need to actually split the middle here. So I need to write 3x squared minus 15x minus 4x plus 20. And I'll do my factoring by grouping. So my first 2 terms I can factor out of 3x, which leaves x minus 5. My second 2 terms, I can take out minus 4, and that also leaves x minus 5. Don't forget to distribute to make sure that it still works. So my factors are 3x minus 4 times x minus 5. So my solutions are x equals positive 4/3 or x equals positive 5. Now, similarly to when we did our radical equations, all right, and really for any equation, you should always check to make sure that you don't have any extraneous solutions. And when you're thinking about with logarithmic equations, right, because you got to plug it back into the very beginning, you want to make sure you're not going to get a negative in the argument, all right? We can't have a negative in there. So when I plug in 4/3, right, if I'm plugging 4/3 into x, I'll notice the one on the right, 4/3 minus 4 is a negative. However, if you were to multiply that 3 times 4/3, right, and you would get 4 minus 7, that's also a negative. And a negative times a negative does become a positive argument. So in this case, the 4/3 is okay. If I plug in 5 for both of those, I get positive also. So both of these are going to work. We just want to make sure you're checking so you don't have any negative arguments. Okay, next one I'm going to do is number 3. All right, so this has the natural log of x. It's only 1 logarithm, and I want to get that by itself on one side of the equation. So I'm going to first subtract that 5 over to write negative 4 minus 5, which is negative 9. Then I'm going to divide both sides by that 3. Negative 9 divided by 3 is negative 3. At this point, I've achieved one of my goals, which is 1 log on one side, and that base is e. So e to the negative 3rd power equals x. So e to the negative 3rd power equals x. We've actually already isolated x here. That's the same as 1 over e cubed. Okay, number 4. Now, number 4, I'm going to use a property before I actually rewrite it as an exponential equation. You technically could rewrite this, but I do see a power right here. So I'm going to use one of my properties that allows me to move it to the front. So 2 times log base 5 of 3x. I highly encourage you to do this and make your life easier in terms of smaller numbers, because now I can move that 2 over with division, and 4 divided by 2 is 2. So now I'm going to rewrite this as an exponential equation. 5 to the 2nd power equals 3x. So that gives me 25 equals 3x, or x equals 25 over 3. Feel free to write it as a decimal or as a mixed number, is your call. I'm going to leave it as improper, and then just take a look and make sure you don't have any negative issues, and we do not, right? Everything would be positive. Okay, so that's 1, 3, and 4 down. Let's keep going. I'm going to do 5, 6, and 7. Then I'll be finished. Okay, we actually did a problem similar to this on our exponential equations quiz light, or quiz, I should say. And so when you're looking at this, you want to actually move everything to the other side that's not affiliated with that base of 3 raised to that power. So I'm going to move the the minus 7 over first with addition. So that's going to give me 20. Then I'm going to divide both sides by that 2 to get 10. And now this is where I would try to rewrite each side of this equation with the same base, but I cannot rewrite 10 with a base of 3. So this is where you're going to take the logarithm of both sides. The reason we do that is because if I have a logarithm on each side of this equation, I can take that power of 4x plus 1 and move it out of the exponent. That's kind of the goal of this. Now you can choose whatever you want. Just to be honest with you, pretty much all the time I use the natural log, all right, because I like using e as my base. But you don't have to. You can always use the common log, log with a base of 10. And this is one instance where I actually would use the common log because of that 10. All right, so I'm going to write the log of both sides. Just make sure you do whatever log you choose, natural log or common log, make sure you do it to both. So now move this power, right? This power can move to the front. So it's 4x plus 1, and that's going to multiply times the log of 3. Now, one thing you should notice here, actually I'm going to back up a second, is that this log of 10 is something that you should know, right? That's why I chose the common log for this. Most of the time I don't, right? But the log of 10 equal to question mark, you have a base of 10. So 10 to what power gives you 10? And that's the first power. So the log of 10, I hope you know by now, is just 1. So now to get the x by itself, it's really just using algebra. I'm going to divide both sides by that log of 3 to get 1 over the log of 3. Subtract the 1 to get 1 over log of 3 minus 1. And then you can write it like this because I'm going to divide by 4. It's going to look kind of ugly here. All right, so minus 1, put that in parentheses, and then divide by 4. You don't have to leave it like that. That's fine. I will accept that. But if you want to make it look nicer, you can actually get a common denominator with this 1 to write 1 minus the log of 3 over the log of 3. And then instead of saying divide by 4 on the outside, you could throw that 4 underneath as multiplies by that log that's in the denominator. Right? If that confuses you, don't worry about it, right? This is absolutely totally fine, but I'm going to stick with this one here. Okay, let's try number 6. All right, number 6, right, remember my goal here. I see 2 logs, right? I want 1 log on one side of the equation or 1 log on each side. I have not achieved either of those goals, but I see logs with the same base connected by subtraction. So one of my property states that I can combine them and my arguments are divided. So x over x minus 1. Now I have achieved that goal. So I can write this as an exponential equation. 4 to the 1/2 power equals that argument. 4 to the 1/2 power equals x over x minus 1. I'm hoping you know by now what it means to raise something to the 1/2 power. That's the square root. So that's 2 equals x over x minus 1. Feel free to make this a proportion if you'd like. I'm just going to move the x minus 1 over with multiplication. I'm going to distribute to get 2x minus 2 equals x. All right, I'm going to move that x from the right side to the left side to get positive x, and move the minus 2 to the other side to get positive 2. All right, don't forget to check. All right, I don't have any issues. All my arguments would be positive. Okay, last one. Number 7. I have the natural log of the square root of x minus 8 equals 5. Right? Again, you do have 1 log on one side, so feel free if you wanted to. You could, using your base of e, turn it into an exponential equation. But I'm hoping your brain sees that I can actually rewrite this as x minus 8 to the 1/2 power. All right, and when I do that, now I can use one of my properties that allows me to move that 1/2 to the front, and it multiplies by this natural log of x minus 8. And if I divide that 1/2 over, right, which I'm not actually going to do, I'm going to multiply by the reciprocal of 2. So 5 times 2 would be 10. So now I have achieved what I think is a simpler version of that. So using my base of e, I'm going to do e to the 10th power equals x minus 8. To get x by itself, I'm going to move that minus 8 over to get e to the 10th power plus 8. And you're just going to leave it like that. I do not need an approximation for that value. Okay, that will definitely be no issues in the argument, e to the 10th power. So even if you conservatively use 2 to the 10th power, that would be a very large number. So subtracting 8, but no issues there. All right, guys, so that's it for this video. I have a lot of questions I worked out that you can check out on the key. And do your best. I know some of these are really, really, really tough, so try to practice them before you actually look at the key. I know it can be easier if you're like, oh yeah, let me just follow the key. It really would help your brain if you tried it first before checking out the key. All right, good luck.